All right, y'all. This is video 3 of 3 in this series talking about the 3 different ways that we can solve these systems of equations. First, we talked about solving by graphing so that you could visually see the point of intersection, the place where the x and y value for the two lines was the same. We then moved to substitution, which handles more how you handle these systems of equations to find their solutions algebraically. And this is our final method that's all about elimination. What I'm going to tell you about elimination is that most students prefer this method. Usually it involves a lot less algebraic reasoning, but that comes with an added emphasis on arithmetic, right? So you had to be good with your things like multiplication, your times tables. You have to be good with the concept of lowest common multiple. But if you are super solid there, then elimination is a method you should consider using frequently because it takes a lot of the algebraic reasoning out of your way. You don't have to worry too much about missing a step in logic there. All right. So, one thing I'm going to stress before we get into this, elimination only works because you know the x's in the two equations are the exact same number, and the same is true of your y's. You know these x's are the same, you know these y's are the same, and that's kind of the logic that elimination is based on. I'm going to explain that a little more further on, but just know for right now, that is the only reason that elimination works as a method. You cannot always do the things we're about to do with two equations that we're about to do with these. So step number 1 in elimination here says we have to arrange both equations so that they're in standard form. What you notice about the bottom one is that is true, right? If standard form says ax plus by equals c, then yeah, the second equation looks exactly like that. But the top one reads as y equals mx plus b, which you know to be slope-intercept form. So we have some work to do with that first equation in turning it into its standard form. Now, luckily for us, that isn't too complicated. All we're doing is we're taking a look at this term 5x that's right here, right? And if standard form wants that term to be over here on the left with the y, then all we need to do is subtract it from both sides because the term itself is positive. And you get rid of positive terms with negative ones. All right? So we subtract 5x from both sides. On the right side, that's going to cancel out with the positive 5x that's already there. And we are left with negative 2. And over here on the left, we've got our y, we've got our negative 5x. I'm going to use our commutative property to write that in the way that it's closest to slope-intercept form, or rather closest to standard form right off the bat. And that is negative 5x. Because y was positive initially, we're going to keep it positive, plus y. And now we have our equation in its standard form. Negative 5x plus y equals negative 2. All right? So that is step number 1 accomplished. We have our standard form equation, whereas initially it was given to us in its slope-intercept form. Now, step number 2 says we have to multiply or divide one equation by a number so that the coefficients for one variable are opposites. It's a lot of vocabulary packed in there. I'm going to break that down for us. So I'm going to go ahead and start by rewriting our two equations. This new one we've created in its standard form. Negative 5x plus y equals negative 2. And the other one that was already there, negative 2x plus 2y equals 12. Let me double check that. Yes. Okay. And we're going to take a good look at the coefficients, or the numbers that are attached to x and y. Right now, the coefficients for x are negative 5 and negative 2. And the coefficients attached to y are 2 on bottom, and because we don't see a number attached to the y up top, we can assume that it is 1. Okay? We're going to think about the lowest common multiple for each of these sets of coefficients. So for the first one, the LCM, lowest common multiple, is 10, right? Lowest number that both 5 and 2 can multiply into is 10. And if I look over here at the y's, the LCM between 1 and 2 is 2. All right? So between the two of our lowest common multiples here, I see that the coefficients for y have the smallest one, and they have an LCM of 2, which means I probably want to work on making it so that the coefficients for my y variable are the ones that I'm deciding to make opposite. All right? So generally speaking, whichever coefficients have the lowest common multiple, that's the one you want to toy with to eliminate, because generally speaking, lower numbers make for easier problems. And we're going to talk about this word opposites here. And that's not too complicated, right? When we say opposites, generally what we mean is positive versus negative, all right? Those are considered your opposites. And so when I'm setting up a problem for elimination, I want to make it so that the coefficients for either my x's, or in this case, we've chosen to work with y, we want to make it so that the coefficients are opposites. And that's because it takes a lot of the guesswork out of this process. It makes it so that we know after this step is complete, we're always going to go ahead and add these two equations together. So if you make your coefficients for your variables opposites, the step 3 is always just going to be adding the two equations together. Okay? So how do we make the coefficients for our y's opposites here? We go ahead and rewrite these. So that is negative 5x plus y. And this is negative 2x plus 2y. All right? If we think about what number would need to be in front of y to be the opposite of 2y, that's going to be negative 2, right? And so we can handle our elimination here. We can set it up for elimination by multiplying everything in that top equation by negative 2. All right? And so I'm going to write over here what the results of that are going to be. Negative 2 times negative 5x is positive 10x. Negative 2 times y gets us our negative 2y we're looking for. And negative 2 times negative 2 gets us positive 4. Down below, we didn't change anything, so we're just going to bring that over. Negative 2x plus 2y equals 12. All right? And so now, as you'll notice, we've set our two equations up to eliminate because the coefficients for y are both opposites. So now we go down here to step number 3. It says to add the second equation to eliminate the matched variable. Then solve for the remaining variable. So all we're going to do here is start by rewriting our equations. 10x minus 2y equals 4. Negative 2x plus 2y equals 12. And like the step says, we're going to add everything together, every single thing. All right? So we're adding these. We're adding these. And we're adding these. So if we look at this first set here, 10x plus negative 2x is going to get us 8x. Negative 2y plus 2y, that's going to cancel out because those are opposites. When we add opposites together, they cancel out. And lastly here, 4 plus 12 is going to get us 16. So by adding these two equations together, we've come to this equation, 8x equals 16, and our y's are gone. They've eliminated one another. Now, remember what I mentioned before, that elimination only works because we know the x's are exactly the same and the y's are exactly the same. You cannot always add equations together in this way, right? Because we don't know between two random equations that x in one is the same as x in the other, or that y in one is the same as y in the other. So this does not always work. However, The one time we can use this process of elimination is when we know we're looking for the place where the x values are exactly the same and the y's values are exactly the same. Because then we can think of the x's and the y's in these equations as like terms, right? We know y up top is the same as y on bottom. We know x on top is the same as x on bottom. So this doesn't always work, but in the case of solving these systems of equations, it absolutely does. And now the only thing we have left to do to get x by itself, divide both sides by 8, which should be familiar from the substitution video. Doing that leaves us with, let me get a proper slash there. There we go. X equals 2. And now we have an x value for our solution. I want you to remember that when you're solving these systems of equations, you're never looking for just one number, right? If you're asked to provide a solution, it should be an ordered pair, unless you're looking at a solution or a situation with no solution or infinite solutions. So because we have an x value, we still have to do work to find our y value, which brings us to step number 4. We just got to solve for the value of the eliminated variable in either equation. We notice that we eliminated y up top, so we're going to use the x value we found, and we're going to plug it in. This should be reminiscent of substitution for you. Once we do that, we're just going to go ahead and simplify until we get a number value for y. Y equals 5 times 2 is 10, minus 2. Y equals 8. So just like graphing, just like substitution, we solve this system of equations, and we end up with this solution, 2, 8. Remembering that x is always first, y is always second. All right? So, no matter which method you use to solve, substitution, elimination, graphing, you are always going to end up with the same number values. As long as you're performing each of the steps in each of these methods correctly, you're always going to end up with the same answer. Okay? And I want you to remember, no matter which method you're using, you're always looking for the same thing. You're looking for this place where these two linear functions cross. All right? I want to thank you guys for watching, and I hope you look forward to the next video.